Good morning or good afternoon, everybody. Welcome back to another week. Hopefully you kind of got the message that we are going to kind of continue on this path and then go through May 22nd. And that'll kind of be the last day of instruction. And then that leaves us that last week, which is usually finals week, to kind of wrap up everything. And if anybody, has some late work or we need to get some things fixed, cleared up, we'll need to do it then. So kind of going to go through May 22nd in terms of instruction. All right, just the weekly schedule here, just kind of get you everybody on the same page. I'm going to try and start posting this on my Canvas page on the home page. That's kind of going to be the goal here. But today we're going to 11:7 video notes, assignment due by 11:59. Canvas conference from 12 noon to 12:30. And also I'm going to go over the homework from section 11:6 that was turned in last week. It was not, a lot of you have some issues, and I'm basically just going to go through that whole homework from noon to 12:30. Okay, I'm just going to sit down and go through all the problems. You need to check your problem assignment and then check the answer key. Now don't forget what I do here. Let me see if I can, is under modules. I think that was the one I wanted, actually. Okay. Yeah, we're just kind of spinning here, and I'm going to turn me off. Yeah, so right there. Once an assignment is due, I will post the answer key, and actually I'll go through it here in a second as well, but you can access the key here and print that off if needed, but I'm going to go through it together with everybody during the conference. And then Tuesday, Canvas conference 8:30 to 9. That's kind of more to go over the work for Monday. You should hopefully kind of try to get it done Monday, and what you have questions on, come in on Tuesday to ask questions. Wednesday, we're reviewing 11:6 and 11:7, and they'll be given a practice quiz, and that'll be due Thursday 11:59. But what I'm going to do is when it's Thursday, once you turn it in, I'm going to post the answer key in the comments section for you to access, but only do that for those who've turned it in. And I kind of give you about till 6 o'clock to do that, and I'll give you some time to look at the feedback. It's still not due to 11:59, but if you get in before that, I'll post the answer key so that you can look at it as well. And then Friday, May 1st, we're going to have a quiz over 11:6 and 11:7. Same format as the last few. Need to have it signed by parent, due by 11:59. But that's kind of where we are at for the week. All right, simplify the following. Let's just kind of we're going to do the first two together, and then I want you to do 3 and 4. I just kind of have to know how to do these. Some of you are getting good with the just understanding with the perfect square, but I'm going to use factor tree just to kind of sync, because I think more people use it that way. So 20 is 4 times 5. And these aren't on your guided notes, okay, for today. So these are just kind of extra, just kind of give you a little bit of feedback or a little bit of practice from before. Looking for a pair, I got a pair of 2s. That goes on the outside. 2 square root of 5 would be my answer. Okay, that would be my answer. Number 2, 4 square root of 216. Don't forget the 4. That's probably the biggest thing I see people making mistakes on. 216, what is that going to be? That is 2 times 108, and 108 is 2 times 64. Ooh, we're going to get a lot of 2s here. 64 is 8 times 8. 8 is 4 times 2, both of them. And then 4 is 2 times 2. And that's easy to kind of get lost because we have a lot of different layers. But let's see, how many 2s do we really have? I got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So I got 8 pairs of 2s. Does that sound right? No, I made a mistake. I got to go back and fix this because 2 times 64 is not 108. That is incorrect. It didn't look right to me. So it's 2 times what? It's 2 times 54. And then that's going to be 9 times 6. That's going to be 3 times 3. And that's going to be 2 times 3. That looks a little better. And so we got 4 square root. And how many 2's do I have? I got 1, 2, 3 2's. 1, 2, 3 2's. And then I got 3 3's. And I got looking for pairs. And I already have a 4 on the outside. Don't forget about that. You bring a 2 out. That takes care of those. You take a 3 out. Anything left together, you end up multiplying back together and multiply these together. So I get 24, and then 2 times 3 is 6. So 24 square root of 6. All right, now take a second. You try number 3. You try number 4. I'm actually going to pause this. Well, actually, no need to. You pause it and then come back when you are done and kind of see where you're at. All right, hopefully you pause it, tried those 2 problems. The answer number 3, here's your answers to the first 2. We already went over those. Answer to number 3 is 6x squared root of 2, and then here's your answer for number 4. 6x squared y squared z to the 4th. And remember, if you ever have an odd exponent, that is when you're going to have a single variable in the radicand. So you got to make sure you should never have like y squared or y cubed or anything in there, just 10yz. Do your factor tree on 360, do the pairs for the variables. Okay. Now here's your answer key from the day before. Like I said, a few of you had some issues with here, go through, check your work. Okay, don't forget the square root of 10. Several of you, the square root of 100 is 10. It is not, you know what that is. Don't make it square root of 10. Same thing with 26. It is 5 when you are done. Okay. Okay, say pause this, look at your homework, fix. Make sure you reduce. I'm going to go through these, all of these on the conference today at noon. And that's 42, 45, 46, 47, and 48. Okay, so you get to have this, and then you also have that answer key. All right, now we're going to get into our guided notes. 11.7. Okay, like I said, we're going to quiz over 11.6 and 11.7 this Friday. We're going to have Wednesday do a review, and then you're going to do a practice quiz. Adding and subtracting radical expressions. Square root expressions with the same radicand are examples of what we call like radicals. Remember, the radicand is what is on the inside of a radical sign. Oops. Okay, it is what's on the inside. Like radicals, 2 square root of 5 and 4 square root of 5, because they both have the square root of 5. 6 square root of x and negative 2 square root of x are like radicals, and these both have 4t on the inside. Unlike radicals, just a constant and square root of 15. That has an x, but that has a 6x on the inside, and that has a 2 on the inside, and that has a 3. So those are examples of unlike radicals, as you should see on your notes. Well, here's the deal. We can add and subtract like radicals. We cannot add and subtract unlike radicals. It's just like variables, like an x and a y. We can't add 6x and 2y. But if you had 2 square root of 5 plus 4 square root of 5, all you got to do is you add the 2 and the 4, gives you 6 square root of 5. 6 square root of x minus 2 square root of x, 6 minus 2, 4 square root of x. Like radicals, you can add or subtract. It's just like combining 2x and 4x is 6x, exactly the same. And just like for the variables, 2x plus 4y, you can't add those together. You cannot add 2 square root of 5 plus 4 square root of 3. You have to have the same inside. Okay, like radicals, we can add and subtract by combining like terms. All right, let's go through a couple cases here. 9 square root of 3 minus 4 square root of 3. All we got to do, 9 minus 4, 5 square root of 3. That's it. Okay, 9 minus 4, 5 square root of 3. 6 square root of x plus 8 square root of y. You cannot add those together. Sometimes you might see this as already simplified. And then if you see the answer, though, like if you, on a multiple choice test, your answer would just be this. Okay, it's the exact same thing. You cannot combine them, so you would just write 6 square root of x plus 8 square root of y. M minus 7, square root of m minus 7 square root of m. Just like when we add x plus 2x, there's a 1 in front of that x to get 3x. If you have the square root of m, there is a 1 in front of there. There is a constant. So we need to take 1 minus 7. And so our answer is negative 6 radical m. All right, this one has 3 terms. Not all 3 terms are like terms, but 2 of them are. 2 square root of xy and 9 square root of xy. Well, we can combine those. 2 plus 9 is 11. Square root of xy plus 2 radical y. You cannot go any further because you cannot combine those two. Now, it really doesn't matter what order you write your answer. So if somebody has 2 square root of y plus 11 square root of xy, those are equivalent. So either one is perfectly fine. But you can only combine the like radicals. Now, is it always that easy? Sorry. Nope. Because sometimes radicals do not appear to be like radicals until they are simplified. So here's the big thing. Here's a key. You have to simplify all radicals in an expression before trying to identify the like radicals. What that means is if you take a look at this one, square root of 45 minus square root of 20, and say, oh, I can't do anything with that, and move on, you're going to miss that one. Because we have to do the factor tree and say whether it simplifies. 45 is 9 times 5. 9 is 3 times 3. So the square root of 45 becomes 3 times 3 times 5, which is 3 radical 5. 20 is 4 times 5, and that's 2 times 2 times 5. So I'm going to treat it like minus square root of 20. So I get 2 times 2 times 5. Let me circle the 3's from earlier. So this becomes minus 2 square root of 5. All right, now we have 3 square root of 5 minus 2 square root of 5. Those are like radicals. You take 3 minus 2 is 1 square root of 5. Now remember, if you have a 1, you don't have to write it. You can just write square root of 5. That is fine. I prefer you write just square root of 5. If somebody writes 1 square root of 5, I'm not marking it wrong, though. But you don't need to write that down. So here's the thing. You just can't automatically look at them and say they're not like radicals. Now, if you got something like square root of 3 plus square root of 5, or say 2 square root of 3 plus square root of 5, those can't be simplified. There, right there, you're done. Okay, so hopefully you recognize that and not go through any work. But we now need to start testing and figuring out. All right, so 9 square root of 75 plus 2 square root of 50. Got to go factor tree on 75. Got to go factor tree on 50. 75 is 3. That's 3 quarters, right? 3 times 25. And 25 is 5 times 5. 50 is 2 quarters. 2 times 25 and that's 5 times 5. So now 9, don't forget that 9. 75 is 3 times 5 times 5. Plus 2 square root of 50, and 50 is 2 times 5 times 5. Pair of 5s, pair of 5s. Now don't forget, when you take a pair, you take 1 5 out and you multiply it there. So it's 45 times square root of 3. Plus, I take the 5 out. 2 times 5 is 10 square root of 2. Now we simplified it. Do we have like radicands? Do we have like radicals? I don't. So you can't actually add those two together. This is our answer, however. You have to simplify it first. You cannot tell me that original problem and just say, oh, can't add them together. You got to go through and show me what they simplified to. Okay, so you get 45 square root of 3 plus 10 square root of 2. Can't add them together. All right, these two actually you can't add together. So let's take a look here. 4 square root of 12 plus 6 square root of 27. 12. 4 times 3. 27. Now, let me go ahead and finish here. 4 is 2 times 2. 27. 9 times 3. 3 times 3. Don't forget about the 4 in front. 12. 2 times 2 times 3. Plus 6. 27 is 3 times 3 times 3. Okay, got a pair of 2s here. I got a pair of 3s here. 2 goes on the outside, becomes 8 square root of 3. And now 3 goes on the outside. 6 times 3 is 18 square root of 3. So now I have 8 square root of 3 plus 18 square root of 3, and 8 plus 18, 26 square root of 3. So those two we were able to add together. Okay, simplify, simplify, simplify. See if you have like radicands. Okay, and then go from there. All right, so for D, sometimes you're going to have 3 terms. So let's see what we get here. And now in this case, you just have a y. That's always going to be there because you have to have at least a y squared or higher for something to come out. So you're going to have a y. So we really need to only worry about the 75. We need to worry about the 27, and we need to worry about the 48. And when I say worry about, we need to do a factor tree on those. 75. 25 times 3, 5 times 5. 27. 9 times 3. 3 times 3. 8. 48 is 6 times 8. 6 is 2 times 3. 8 is 4 times 2. 4 is 2 times 2. So here's what I got. I got square root 75y, which is 3 times 5 times 5 times y, minus 2. Don't forget that 2. Square root of 3 times 3 times 3 times y. That's your 27. Plus 48. I got 1, 2, 3, 4 2s and a 3. 2 times 2 times 2 times 2, a 3. And then don't forget the y. All right, what are these going to look like here? Pair of 5s. So it's going to be 5 on the outside, square root of 3y. 3 goes out. 3 times 2 is 6. I got a 3y on the inside. Plus 2 pair of 2s. Remember, each 2 that goes out, there's a 2. You multiply those two together, you get 4. So it's plus 4 square root of 3y. They all have square root of 3y. These all can be combined. 5 minus 6 is negative 1. Negative 1 plus 4 is positive 3. So 3 square root of 3y would be our final answer for that. So now we just simplify, simplify, simplify. Okay, for that. 3 square root of 24 minus 6 square root of 150. So you got 24, you got 150. All of this comes down to being good at reducing these radicals. Okay. The better you are at that, the better, easier these problems are. And that's for the rest of this chapter. 24 is 4 times 6. That is 6 times 25. And that's 2 times 3, 5 times 5. Okay, so 3, 24. 2 times 2 times 2 times 3. Minus 6. 150. I get 2 times 3 times 5 times 5. One pair of 2s. Remember, 3's already out there. Multiply it by the 2. 2 times 3 on the inside. 6 is already out there. Take out a 5. Square root of 2 times 3. Now, you probably could have done this in the first step. 3 times 2 is 6. 2 times 3 is 6 minus 30. Square root of 6. But you have to do that. You have to get down to this. And 6 square root of 6 minus 30 square root of 6 is minus 24 square root of 6. Okay. For that. Now, the easier ones already have the same radicand. You don't need to do anything. 10 square root of 2 minus 3 square root of 2 is 7 square root of 2. Nothing to do. You just need to combine the outer terms, outer constants. 10 minus 3 is 7. Once we get into the ones where they don't match up, you've got to reduce first before you come up with an answer. All right, just one more here. In this case here, the perimeter of a triangle. Perimeter, you add up the 3 sides. Now, here it says give the answer as a radical expression in simplest form. Okay, at no point in this section, in this chapter, will you give me a decimal answer. You cannot just stick these in your calculator and get a decimal answer. So what we need to do is we need to take 3 square root of 20 plus 13 square root of 5 plus 10. 3 square root of 20. That reduces into 2 times 10, and that's 2 times 5. So that becomes 3, 2 times 2 times 5, plus the square root of 5 doesn't reduce. Leave that, and then you get a 10. 2 goes out. I get 6 square root of 5 plus 13 square root of 5 plus 10. Well, you got 3 things to add. Only 2 of them can be combined because only 2 of them have square root of 5. So that's 19 square root of 5 plus 10. Well, the only way you can do that, technically, since we're asked for perimeter, we're asked for, you got to put a unit on there. Well, those are all millimeters. You can just do this. Put that in parentheses. Put a millimeter on the outside. So you just say 19 square root of 5 plus 10. That's your answer. That's what you get when you add those together. Nothing, no other way we can write it. Now you can flip it around and put the 10 in front. So if somebody puts 10 plus 19 square root of 5, that's definitely fine. Those are the exact same things. Okay. But just make sure perimeter. Perimeter means sum. You're adding those distances up. Okay, let's see here. Why do I have a blank page? Huh. All right, for some reason it's coming up blank, but your assignment is page 813, 2 through 14, all. Okay, little word here. Some of you are just starting to get in the habit of using this photo math or whatever thing, and you're just writing down what the photo math gives you. Don't do that. I'm not going to give you credit. If you want to use that to check your work and help you get the right answer, that's fine. But those of you who just turn this in and it's the work, 'cause I got the app too. I got the app on my phone and I just type it in so I know exactly what it's telling you. Those of you who aren't doing it the way that I tell you, we're showing you, you're just going to get a 0 for the homework. I'll tell you to redo it. If you want to use it to help check your answers, that's fine. That's awesome. But if you're just using it to do your work, 0. Got it? All right. Just do your work. Make life easy on yourself so we don't have to redo things. Okay. This is due Tuesday evening, 2 through 14 all, page 813. All right. Have a great day.